All right, so our fourth and final Algebra 1 at least factoring technique. We'll continue to use these and we will add some more sophisticated stuff, but they're quite a bit more sophisticated. So this is the last one for this year before we can start doing stuff with factoring, which we'll do Monday. So, difference of squares. You guys looked at those investigation problems. How do you know when you look at something whether something's difference of squares? That's probably the hardest part, I guess, because doing it's really easy, as you're going to see. How do you know each one of these is difference of squares factoring? There's the difference. It's got two terms. It's a binomial, so you can only use difference of squares on binomials. Binomials that have a subtraction in between. And you can only use it on binomials where the pieces on both sides are what? Square quantities. There's something that's squared. Now that can look different in some cases, so let's try each one of these out first, okay? So, difference of squares. You set it up just like a standard trinomial. So you start by writing down some parentheses. That's kind of the way we started out in the other cases as well. And then you ask yourself, what's the first thing being squared? Well, in the first term, what is being squared?
X.
X. And you put that in the first two slots. And then you ask yourself, what's the second thing being squared?
4.
Yeah, there's a 4 there, but what is being squared to produce that 4? The answer is 2. You can also think, if you like square roots, which I don't think you guys have very much experience with square roots, we're going to learn more about them this year. You can also think of just what's the square root of 4. Yeah, that's another way to think. So, and then what are the signs in here? One's going to be negative and one's going to be positive. It doesn't matter which. That's the beauty of difference of squares. You don't ever have to worry about the signs because in difference of squares there's always one that's negative and one that's positive. If you don't believe it, check it. 2 times negative 2, negative 4. And if you add 2 plus negative 2, you get 0. And there you can see that there's no x term when you do it this way. So this should make sense with everything we've already done. Okay, so second problem, x squared minus 256. So first you got to ask yourself, is this difference of squares? Well, is 256 a square number? I'm guessing you guys don't know. So you might look at your calculator, go to your calculator and check. It is 16 squared. Done. Okay? This one looks different, but it's not. It's still a binomial, it's still a difference, and I argue at least that there's square things on both sides.
Yeah. 8 and 3.
What's being squared here? 3 and w is being squared there. So I put that in the first 2 slots. What's being squared here?
8 and y.
8 and y. And difference of squares always goes 1 plus, 1 minus, your choice, switch order. Okay? That's it. That's all difference of squares is. So now let's look at some problems that have some difference of squares maybe, but also those other types of factoring. That's like the back of your worksheet. Okay, so what if they don't tell us specifically what kind of factoring to use? That's pretty much always reality after now. So how do you factor? Well, let's think about it. There's multiple options in some cases too. So number 1, you guys have any ideas?
That is standard.
Is A1? A is not 1. So you guys could do this like we did last time, the third longest factoring technique. You could go 2 times negative 64 and do the 4-step algorithm. That is really important not to forget if you want to be successful. You can still be pretty successful. Depends. It depends without it. But. So we could do this one that way. We get a really big number though, wouldn't we? 2 times negative 64. It's like negative 138, 128. Yeah? So then we could use our calculator to help us. I think there's an easier way to do this problem, if you're alert and alive. Is it difference of squares? Go through the list. This is what you should do on your fingers or in your head. Is it difference of squares? Clearly no, there's more than 2 things. Can you just look at the last number? Clearly no, because that's not a 1. What's that leave? What's the first thing we learned? What they share. Did they share something? not x. There's no x there. But they all have a 2. So pull it out and watch. The other process would totally work on this one too, but I have a faster way. If you just pull out a 2, let's see what happens. 64 divided by 2 is 32. It's a number we see a lot in Algebra 2. And then look at that guy and say, does that guy factor more? The answer is yeah, it's a standard trinomial. A is now 1. You guys see there's nothing there now. So A is now 1, so we should look at factors of 32. Like 8 times 4. Is that going to give us 1? Nah. 32 times 1. Nah, it's not going to give us 1. 16 times 2. Is there anything else? I think that's it. So this guy would be non-factorable. So let's change the problem a little bit and make it factorable. Okay, so all the ones I gave you are fully factorable on that worksheet, all of them. Okay, just have to wonder. So how can I make this be factorable? How about I make this, I think 2 or negative 2 would work. Very good, Richard. So if this was 2, what would this have been to start out with, guys? Yeah. So now which one of those combinations is going to produce this 2? Oh, it's still not going to work, is it? The distance between 8 and 4, I'm wrong. I thought that would work. Sorry. It's a good suggestion. I think we need this to be like a 4, don't we? That would work. So if this is 4, what should this number have been? 8. Okay. Now this guy's going to work. Not exactly 8 and 4, but which one of those is negative? 4. There we go. Now we've got it. Nice. So now we're going to go 2, and this guy's a completely factorable standard trinomial now. So we agreed that negative 4 and 8 were going to work. X and x, let's check it. X squared minus 4x and 8x. That's going to give me 4x. This times this is negative 32. Check. You can distribute your 2 through to get all the way back up to here. Okay? So this one would have also worked, like I said. If you want to do 2 times negative 64, do the 4-step algorithm, you can. I usually like to avoid it because it's long. So sometimes you can't avoid it. All right, let's look at number 2. Any ideas? I think there's several ways we could do this one. Difference of squares. You guys want to start with difference of squares? Do you have a difference? Do you have squarey stuff? Clearly, right? I'm guessing some people watching the video and some of you guys are going, that's not a squarey thing. But it is. It's just squared squared. Yeah? So, this does work with difference of squares. What's being squared here? X. So that goes in the second 2 spots. We'll put our minus and our plus we know about. What's being squared to give you x to the 4th power? Not just x, but x squared, right? Thinking abstractly, well, not abstractly, thinking a little bit, x squared squared, remember that's power to power is multiply. It's 4. Is that done? The answer is no, and most of the ones on your worksheet are like 1 step. I gave you a few 2-steppers. They all could be divided by x. I like that, but turn it into one of the factoring techniques you know. They all, Taylor's saying, have an x, don't they? So let's pull the x out of both. These share an x. What's left? X minus 1. These also share an x. That's x plus 1. So how many factors did this guy end up having? 4. It has 4 factors. I don't think it's a tetranomial because if you expand it out, don't you end up getting back up to here? We'd have to check that by doing lots of distributing, but okay. So 2 steps on that one. Notice, first we used difference of squares, then we used what they share. Now I'm guessing if you're watching the video, or you guys, try this problem another way. You could do it in the reverse order. What did these share up here? X squared. If you pull that out, you'll have to do difference of squares next, and you'll get the same answer. Okay, so I challenge you, if you're watching the video, try that and see if it's the same answer. Last one for us for today, number 3. We're going to look at the last number and combinations of it. Well, there kind of isn't one, so no.
Can't be the.
Is it
Can't be squares.
difference of squares?
No.
No, it's got a plus, so that leaves what they share. This is the thought process you want to go through. So what do they share? X and 10. I pulled 10 out of 120. If I divide, I get 12. So having a brain fart there. I pulled one of the x's out, so one's left. We pulled all of that out. And now looking at that, I think it's totally done. So when you're on that back part of the worksheet, make sure once you've done one factoring procedure, ask yourself, can I factor a little bit more or not? Did either one of these share something? Is there difference of squares here? I mean, there definitely could be, so. All right, you guys are set. Okay, just for anyone who's curious, I thought I just couldn't resist. I'm gonna go through and factor this one the other way. So what we said a second ago was that, guys, was that these two terms share x squared, right? So the other way to do this problem, if you say they share x squared, I'm gonna pull it out. What's left? If I pull x squared out of this, another x squared is left. If I pull x squared out of itself, it's just 1. There's a minus in between. And then you got to look at that and say, is it done? Is it really done? And I think clearly, hopefully by now, by doing that worksheet, you'll see that this is not done. This is difference of squares. It's a difference of squares. What's being squared here is x. What's being squared here is 1, because 1 squared is 1. Minus plus. There you go. If you look at the work that we did the other way, it's the exact same problem. I think we had one of these x's like over here or something. Or maybe it was in the middle, but that doesn't matter. I mean, it's the same answer. So.